Rahim. My name is Asif Rashid, and I'm manager training at Asian Institute of Industrial Air, the pioneer institute in Pakistan to address the area of industrial air engineering. So we actually address the area of compressed air and industrial air, which unfortunately is not addressed properly either in the universities or in the industries. The formal training, formal body of knowledge on this subject domain and this specific domain is not available. So we are trying to bridge the gap to, uh, to reduce the wastages in this area. And today's webinar is one of the effort in these bridging the gap efforts. So before further delay, I would request our guest speaker for today's session, Mr. Hafazat Imran, to share his screen and start his session. So one thing I should mention here, that if any one of you has some question, they can ask question in the chat box so that all those questions will be addressed. So I would request the Hafazat Saab to please unmute his mic and start the session. So Hafazat Saab, over to you, sir. Please give your brief introduction and start your session.
Thank you very much, Mr. Asif. I'm Hafazat Imran. I'm having an experience of more than a decade in the compressed air systems and the nitrogen generation systems. First of all, I would like to welcome you all on this webinar, which we are going to conduct very shortly. And the purpose of this webinar is to give participants an overview about the nitrogen, the benefits of the nitrogen, and the danger of using the nitrogen cylinders. So we'll be covering all these topics in a brief. Today's webinar will be leading to another one-day certified program, which we will be going to announce very soon. So let's get started. And before I start, I would request everyone, if you have any question, please drop it in your chat box and we will reply you accordingly. So let's get started. I'll try to give you a overview from a very scratch, basically. So because I can understand that the few participants would be new, and so we are starting from the scratch. So what topics we are going to cover in today's topic is that introduction, industrial applications of the nitrogen, and the benefits of on-site nitrogen generation. We will also discuss about the nitrogen processes and the technologies, and how you size the nitrogen generators, and the hazards of using nitrogen cylinders.
Sorry for interruption, Hafazat Saab. You can allow share your screen. Your screen is not visible to the participants.
Okay. Give me a second, please. I hope now you can see the screen, right?
Yes, sir. Your screen is now visible.
Thank you, Asif. In today's topic, we are going to cover about the industrial applications of the nitrogen and the benefits of having on-site nitrogen generator. We'll also discuss about the processes and the technologies we are using at the moment. And we will also try to give you an overview about that, how we size the nitrogen generators. And we'll also discuss the hazards of using the nitrogen cylinders. So, as all of you know, that the air is composed of 78% of the nitrogen. So, it is always very easy to extract it from the air, because air consists of 78% of the nitrogen, 21% of oxygen. So basically, you need to separate the nitrogen from the air. And what is the nitrogen? This is the question which comes in your mind first. So basically, nitrogen is a colorless, tasteless, and odorless gas, right? And this gas is an inert gas, and is used in many processes across the general industries. Why we use the nitrogen? This question may come in your mind, that why we use the nitrogen. Basic purpose of using the nitrogen is to prevent the oxidation, so that you can avoid the fast oxidation can create explosions, can create fire. So to prevent that, we use nitrogen, and to give inert environment if there is any possibility of fire or explosion. And when it comes to the food, with the oxygen, the foods get rotted. So to avoid the rotting, we need to slow down the oxidation process. So that is why we use nitrogen in our processes. Similarly goes with that the metal things. In the metals, the corrosion happens if the oxygen is there. So we need to remove this oxygen from the system. So in the old days, we used to buy the ice. But as we progress, as the human progresses, we are making our own ice. So this similar thing happens with the industrial gases. There was a time when people used to buy the nitrogen in bottles. And by the way, even today, people are using the same method. So now, if you can produce your own nitrogen, why you need to buy it, right? So basic purpose is this, that and our emphasis would be on producing your own on-site nitrogen. So what is nitrogen used for? So the basic purpose that I have told you earlier is to eliminate oxygen from the air environment, because it inhibits the bacterial growth in the food, beverages, and the pharmaceutical processes. So these are the very critical processes where you would not like oxygen to be there. So to prevent that bacterial growth in food and beverages and pharmaceutical processes, you need the nitrogen. Similarly, to prevent the oxidation of the metals, polymers, and chemicals, you need the nitrogen. And it strongly reduces the risk of spontaneous combustion and explosion. So when it comes to the oil and gas sectors, nitrogen is very important. It plays a key role as it prevents the risk of spontaneous combustions and explosions or fires. So at the moment, the distribution of the nitrogen is through the three networks where we can produce nitrogen in three ways. The first one is a cryogenic method. That is, you use trucks and you use the cylinder bottles, which is commonly used nowadays, especially in Pakistan market. So the cryogenic method, the way of distribution is through the pipelines and through the truck and on-site. Then comes the membrane method. You can also separate the nitrogen by using the membrane. And the most famous and now the most, you can say, the latest technology is the PSA technology. The PSA technology is an on-site method of producing the nitrogen. So you can produce your own nitrogen whenever you want to, and according to your need, according to your purity needs. Now, let's have a look on the applications in the industry. Right now, there are so many applications in which nitrogen is used, like metal cutting. In blanketing, we are using the nitrogen, like injection molding, drilling. You are using in firefighting, metal annealing, food preservations. You also use nitrogen in cleaning and purging of the pipes, and in the soldering processes, you are using this nitrogen. So I have only mentioned few of the applications. Just wanted to share with you that there are so many applications where nitrogen is used. So it is a very important gas in the general industry. So let's have a look on the industries that are using the nitrogen at the moment. Electronic industry, transportation, oil and gas, steel, food and beverages, marine, chemical industry, mining industry, glass industry, pharma industry. So you just name it, and there would be an endless list of these industries you will find who are using the nitrogen in their process. So there are so many industries using these nitrogen in their processes. Now, I want to share with you that the most, you can say, the latest technologies are the membrane technology and the PSA technology. Okay. According to your purity requirement needs, you select the method of producing it, right? So if your requirement is around, you can say 95%, the 95% applications are in tire inflations, like in oil and gas, where you do the blanketing, and even in the air of the tires of aeroplanes, you use the same gas with the lower purity. So you do not need a PSA technology over there. You can produce the nitrogen by using the membrane. If your requirement is above 98% and it goes to 99.999%, then comes the PSA technology. PSA is basically a pressure swing adoption technology, which I will explain in the later slides, and will show you that how it works. So when we talk about the food and beverages, and we talk about the CNC machine or the electronics or the food storage, these are the areas where you require a high purity nitrogen gas. So to produce the high nitrogen gas, purity nitrogen gas, we use the PSA technology. How it works, I'll explain later. So there is a video on the PSA technology, which I would like to show you at the end of my this webinar session, so that you can have a very good idea that how it works, basically. So why you need to shift to the on-site nitrogen generation? For this, I need to tell you the benefits, right? You need to see what benefits you are getting out of it. If you are using the on-site nitrogen generation, you will be benefited by which parameters we will discuss one by one. So the first main benefit is that you get the freedom from the fluctuating liquid nitrogen and delivery cost. You know, the liquid nitrogen cylinder comes with a cost. There is a cost of the cylinder, there is a cost of the gas itself, and then there you have to pay the transportation for that gas as well. So it means you are always dependent on that third party for your nitrogen needs. So in case of any emergency, you can really end up with some big problems, right? If you do not have your own nitrogen. For this, we always recommend our customers that if you can produce your own nitrogen from the air, you just need to have a compressed air and a gas generator, and that's all you need to produce your own nitrogen. So why not if the system is so simple? So let's discuss the benefits one by one, and I'll explain the benefits to you one by one. You can enjoy the lowest price per volume of a gas. That means that you can, for example, if you need a purity of 98% and you are getting it from the third source, that is through the cylinders, and they are giving you 99% purity. That means that 99% is not required for you, right? So what you are doing, you are paying the extra cost for that. So in on-site nitrogen generation, you can produce nitrogen according to your purity requirements and according to your purity needs. And when it comes to the saving, you know, nowadays we talk a lot about the cost cuttings and cost saving things. So you can really potentially have a savings of like 40 to 80%, depending on the liquid nitrogen market prices, right? So the return on investment is really very, very good when it comes to the on-site nitrogen generation. And usually the return on the investment is within 9 to 24 months, right? Depending on the current usage, depending on the current equipment you are using, right? And then you have the one very good thing is that you can say the goodbye to the complex long-term contracts with the third party who are supplying you the nitrogen at the moment. You can really straight away ask them a goodbye. Purity levels you can set as per your requirements. You can and even you can reduce the risk of employees' injuries from the storage tanks or exposure to delivered liquid nitrogen. One more thing that you really reducing the carbon footprints, right, by eliminating the truck delivery. And the most far important thing is that you are 24/7 availability of pure nitrogen gas. That means you can produce your own nitrogen whenever you want to, according to your requirement and according to your processes and according to your purity requirement. So it is available 24/7. You are not dependent on or ordering or reordering or the storage logistics. There would be no cost anymore for the logistics and for the storage. And it is easy integration into the plant's current compressed air system. So when it comes to the general industry, you know that most of the customers, they are already using the compressed air. So I have told you that for the generation of nitrogen, you just need to have a compressed dry air, number one. And secondly, you need a gas generator. So if you have already compressed air system, you just need to put a gas generator in front of it and you can have your own nitrogen. So these benefits to me is, they are all very attractive basically. So I hope you have the same feeling about the benefits. So let me show you an overview of this whole nitrogen package. Basically, it starts with the compressors. You put the compressor, because I've told you that to get the nitrogen, you need the dry and compressed air at the inlet of the nitrogen generator. So this is the basic requirement, right? And to get that, we need this instrument air setup. In the instrument air setup, obviously, most customers have already this. You need to have a compressor, then there is a wet dryer, right? And after the wet dryer, there are a filtration system, and then there is a dryer. And after the dryer, you put the dry air receiver, and then that dry air receiver gives the compressed dry air to the inlet of the nitrogen generator. From the nitrogen generator, you can produce your own gas according to your own requirements. So this is an, I was talking about the overview of this all nitrogen train, right? The all nitrogen package. So it starts with the compressor and then come the air receivers. And then that wet air has to be dried because it is the requirement of the nitrogen generator that the air should be compressed and dry. So after the dryer, you can put a dry air receiver before your nitrogen generator, and that nitrogen generator will produce, can give you a purity of like 99.999%, and you can use that nitrogen air directly into your application or your process. So there are a few benefits if you producing the in-house nitrogen. It's a full autonomous operation, right? Without interruption, 24-hour and 365 days in a year. So this gives you a very big advantage if you compare it with your dependency on the third parties on this nitrogen cylinder bottles. Further, you do not require any manual handling. You know, because you are producing and you are using directly into your system. So you do not need the manual handling, a workforce or a storage things. All these things are eliminated if you are using this method of in-house nitrogen production. And minimal maintenance cost. The maintenance cost is almost negligible. I'm saying this because in PSA technology, we use carbon molecular sieves, right? And carbon molecular sieves has a pretty long time. So, and you do not have to change, there is no motor involved, there is no, you do not have to change the oil. So the maintenance cost is very minimal. So if you decide what you get at the end of the day, you get the peace of the mind, right? Because you are producing your own nitrogen, you are producing according to your requirements, you have eliminated all other factors which causing you a big cost, a significant cost. Those all factors are eliminated. So let's have a look on the PSA working principle. As I have told you that PSA is the latest technologies and is commonly used nowadays for the production of 99.999% pure nitrogen. So basically pressure swing, PSA stands for pressure swing adsorption units, right? What happens in these units? They separate the nitrogen from the air, number one. How do they separate it? They use particular special sieves called carbon molecular sieves. And then there is, I've told you that there are two towers involved in this. And then the second process of regeneration starts in the second tower. Let's discuss the two phases in the PSA technology. In the PSA two phase, the first phase is of adsorption, right? Adsorption means that what happens when you pass the compressed air through the molecular sieves. The carbon molecular sieves trap the oxygen molecules. They are being trapped because they are bigger in size, and they let pass the nitrogen molecules to the second tower. And the sieve continues to absorb oxygen till the saturation point. So it's like, I can give you an example of a sponge. You know, what happens if you put a sponge in water up to certain limit, that sponge can absorb the water. But at certain level, a saturation point reaches. Similar is the case with the sieves, like carbon molecular sieves. In carbon molecular sieves, when there's capacity of absorbing further oxygen finished, the process just get halted, and the supply of the compressed air stops, and at the low pressure, the carbon molecular sieves, what happens, they release the oxygen molecules to the atmosphere, and the same process starts in the second tower. That is the regeneration process. The entering air stream is cut off. The oxygen is able to leave the tank at low pressure, I've already told you. And in PSA unit, normally two connected tanks work together. So what happens when it goes to the second tower? The same process happens in the second tower. And these both towers are switching time to time, and they are generating, they are on the adsorption and regeneration process, which is also called a desorption process. So it is a very simple process, basically. You might have heard about the carbon molecular sieves. If you do not, then I can explain it to you. That carbon molecular sieve is, you can say, is a new and one of the few non-polar absorbent that specializes in separating oxygen from the nitrogen under the normal temperatures and the pressure. So it is very important part in the natural gas processes. So carbon molecular sieves, what they do, they act as a absorbing material, absorbing material of oxygen, molecules of oxygen. They absorb the molecules of oxygen, and they let pass the nitrogen molecules, right? So that was the PSA technology. But then there is another technology which is called a membrane technology. The membrane technology basically works on the same principle, right? You have to push the compressed air through a set of polymer fibers instead of the carbon molecular sieves. So what happens as the compressed air moves through the membrane, the molecules of the nitrogen are separated from the other molecules, right? So again, the principle is saying the polymer fibers does allow some molecules to pass on and does not allow most of the molecules to pass through it. So what happens? The oxygen molecules are trapped, and the nitrogen molecules, it allows the nitrogen molecules to pass, right? So you are getting the nitrogen according to your purity. If the purity level is less, then you can put another filter system after the first process. And putting the further these membranes, you can enhance your purity levels. So if you have an idea what does this panel looks like of the nitrogen generator and what parameter it is giving you. So you can see in the diagram that it is you can see the air inlet pressure gauge. What is the inlet pressure? The inlet pressure is very important because there is a drop of 1.5 to 2 bar over the nitrogen generator. So if you are not getting the right amount of the inlet pressure, you won't be getting the right amount at the outlet. You can also see the nitrogen outlet, the pressure at the outlet, right? You can also see the other displays which can show you the presence of oxygen particles in the nitrogen, and there is a very simple on and off switch. Basically, this nitrogen generator is like a plug and play system where you can just plug in from the one end and can get the nitrogen from the other end. So this is a very simplest unit through which you can produce your on-site nitrogen whenever you want to. So now some interesting things are coming up. How to size your nitrogen generator. So this question might comes in your mind that how do we size, how do we know our requirements? To size the nitrogen, there are three main parameters. Those three parameters are: number one, pressure, then comes the purity, and then comes the flow. Pressure is basically outlet pressure, right? Outlet pressure, the pressure, or you can say the working pressure, which you need at the point of working. Different applications have, as I have already told you, that different applications have different purity levels. So according to your need, you can select the nitrogen generator. So you must need your your requirement of purity. Then the flow is basically a free nitrogen delivery in meter cubics per hour or meter cubic per minute or in any unit, right? But you need to know that how much flow you will be requiring to size the correct solution. So these are the three basic requirements which you need to know if you want to correctly size your nitrogen generator. But what happens that most of the companies, manufacturers, they do have their own calculators, right? For the sizing of the right amount of, for the sizing of the right generator. What they do is that they consider some other parameters as well, like the temperature at the inlet, like the pressure at the inlet. Pressure at the inlet and the temperature at the inlet plays a very significant role in the final free nitrogen delivery, right? The flows really depending on the temperatures and the pressures at the inlet. So give me a second, please. Okay. The calculation program of manufacturer selects the correct nitrogen generator for you, right? So you will be asked to enter the following input data. As I've already told you that you may not be bothered about this thing that how we size the right nitrogen generator. A manufacturer will do this thing for you, right? So you just need to give the required nitrogen flow you will be requiring, and you need to tell the pressure you will be needing at the outlet and the purity you will be requiring at the outlet. You need to give the inlet pressure and the inlet air temperature also, because this is very important. And then the program or the calculator or the manufacturer will return the most suitable size of nitrogen generator and the nitrogen vessels. So what happens, what it looks like to install a multiple nitrogen generators. So if you see this diagram, and there is a situation where you have to install the multiple nitrogen generators, how would you do that? That's again not a very complicated process. After the air coming out of the air tank, this is basically a dry air receiver tank, right? So this dry air and compressed air is going into the generator A and the generator B. So I have already told you that there is a drop of 1.5 to 2 bar over the nitrogen generator. So keep this thing in mind while sizing your nitrogen generator. So from the two nitrogen generators, we are receiving nitrogen in two different tanks, tank A and tank B. And from the tank A and tank B, there is a one outlet point for the nitrogen. You can put two lines together, and you can combine and open that line in one outlet. And from that outlet, you can use nitrogen directly into your application or wherever you want to. So this is the diagram which shows you that how do you install the multiple nitrogen generators. So let's talk about the market players in the existing market players who are manufacturing the nitrogen generators. Atlas Copco, Dominic Hunter, Oxymat, Compare, Inmatec. These are the European manufacturers. And then you can see AMEC Industries, Marcopor. These are basically the Turkish origin manufacturers, and then the Gamma, Gascans, and so many others basically. So just wanted to tell you that there are many players who are manufacturing nitrogen and giving the PSA technology solutions to the general industry. Again, sorry for just a second. So, this is a huge market of nitrogen, and it has to be segmented in some way. So based on the geography, the global nitrogen market is segmented into the Asia Pacific zone and the North America zone, South America zone, Europe, Middle East, and Africa. Asia Pacific, believe me, was found to be the major region of this market. And when it comes to the Asia Pacific market, then China, again, is the largest consumer of nitrogen in our region. Unfortunately, the major companies in Pakistan, they are not manufacturing. They do not have that manufacturing facility at the moment where they can produce their own on-site nitrogen, and they can start getting benefits out of it. So, dear friends, what we conclude, that's very important. We conclude that you have to forget the dependency on other alternatives, right? And start producing your own nitrogen. So this is the time when you can start producing your own nitrogen. And you have to forget about the bottles. Forget about the bottles because it is the past. And forget about the delays. And forget to pay the nitrogen price. And that means that if you see this pyramid, on-site nitrogen generation comes on the top because it is the most cost-effective method for producing nitrogen generation. So this is the end, but before we end, I would like to show you a very small video on the working of this PSA technology.
Sir, thank you so much for your time and your sharing your knowledge for today's session on on-site nitrogen generation. I will be thanking you to the core of my heart. So I will share the inquiries and the emails which we have received with you, and I will share your contact address with these participants who need it, and I'll try to connect you so that the participant who want to learn more could contact you directly. So from now, I would like to say thank you to all of the participants who joined this webinar. So this webinar is concluded for now. And for anyone who wants to learn further for one-day training course on nitrogen generation can register through the given link in the chat box. So thank you so much, everyone, for joining today's webinar. Goodbye.
Thank you very much. Thank you very much, everyone. Thank you very much for joining. Take care. Bye-bye.